Okay, so this time we're going to discuss our example number 2. So in example number two, I'm going to make use of the function which is on your module, which is equals to x minus 2 over x plus 2. So first thing is we're going to get the domain. So again, remember the domain is your input. What is the value of x that you're going to substitute to the function? Be sure it should not be in undefined if it is a fraction. So this time we're going to consider our denominator, which is x plus 2. So what makes this denominator, what number are we going to substitute this x to make this 0? So it is negative 2. So as what we have discussed earlier, so x is an element of a real number such that x should not be equal to negative 2. Okay, so again, that is our domain. X should not be equal to negative 2 because this denominator, if we're going to substitute negative 2 to x, then it will become 0, so it will become undefined. That's why negative 2 is not included. So we already have our domain. Now let's proceed to our y-intercept. Remember, in getting our y-intercept, we are going to substitute the x variables. We're going to substitute x variables to 0. So we have now x minus 2 over x plus 2. So it will become 0 minus 2 over 0 plus 2. Okay, so ang x na to, we substitute it by 0. So we have now negative 2 over 2. So negative 2 divided by 2, that is negative 1. So that is our y-intercept. Next, we have the x-intercept. So how are we going to get our x-intercept? We are going to equate our numerator by 0. So what is our numerator here? So since our numerator, since our numerator here is x minus 2 and our denominator is x plus 2, so in getting the x-intercept, so we're going to use the numerator. So we have x minus 2, and we're going to equate to 0. So we have x is equals to positive 2. So that is our x-intercept. So our previous example, we have 2 x-intercept, but in our example 2, we only have 1 x-intercept. So again, it depends upon the function that is given. So it does not really need to have 2 x-intercept, 2 y-intercept. Again, it depends upon the function. So let's proceed to vertical asymptote. So vertical asymptote. So we have in vertical asymptote, again, we are going to equate the denominator by 0. So x plus 2 equals to 0. So x is equals to negative 2. So take note of the numbers that we have. And since we already have the domain, the y-intercept, the x-intercept, now let's have the horizontal asymptote. So how are we going to find the horizontal asymptote? So in getting the horizontal asymptote, we are going to consider the degree or the exponent. Yes, the exponent. So given our we have x minus 2 over x plus 2. So what is the exponent of our leading coefficient? So we have 1 is equals to 1, or n is the degree of the numerator is equals to the degree of the denominator. So we are going to, based on your page 18, if they are equal, then what happened to our horizontal asymptote if they are equal? So if they are equal, we are going to consider the leading coefficient or the numerical leading coefficient, so which is diba na 1 diri so that is 1 over 1, or that is equals to 1. So our horizontal asymptote is 1. So you can see, please refer to page 18. Why did we divide by the leading coefficient? So page 18, refer to page 18 dito sa ubos. N is equals to M. The numerator of the degree of the numerator is equals to the degree of the denominator. That's why we have the leading coefficient numerator divided by the leading coefficient of the denominator. So we have 1 as our horizontal asymptote. So after that, we are now going to we can have first the sign table before we're going to graph anything. So we're just going to put it here on the other side. So we are going to have the sign table. So in the sign table, we have, of course, we're going to find the critical values. So we do not have to transfer this one. It's already on the form. So we have now equate the numerator and equate the denominator to have our critical values. So we have x minus 2 equals 0. So we have x equals to positive 2 and x plus 2 equate to 0. Then we have x is equals to negative 2. So those are our critical values. So we are now moving on to having our graph. So we consider if we're going to plot that one in a number line, so this is 0, negative 1, negative 2, positive 2. So we have here, so we are going to consider this part going to the left, this part in between, and this part also going to the right. So we have x is less than negative 2. Okay, then x is in between negative 2 and 2. And x is greater than 2. So we have now x minus 2, that is our numerator. Then we have x plus 2, that is our denominator. Then we have x minus 2 over x plus 2, that is our function. Okay, let's see. So before that, we're going to have first our x. So if we're going to question me, ma'am, it's just the same in the sign table in page 16. Yes, but then we can have different x values. Say, for example, in my x, I will have negative 10. Since it is less than negative 2, then in my value of here in between negative 2 and 2, I can have 1. And then if x is greater than 2, then I can have 20. Why not? Okay, so let's move on to the sign. So if I'm going to substitute negative 10 to x minus 2, the answer would still be negative. Then if I'm going to substitute 1 in x minus 2, then still it would be negative. And if I'm going to substitute 20, 20 minus 2 is 18, or that is a positive. Next, negative 10 plus 2. So I have utang G's, but I have cash dos still. Utang is larger, so it's still negative. Next, I have cash 1 and then cash 2. So 1 plus 2 is 3, so positive. Then I have cash 20, then another cash 2, so 20 plus 2, that is 22, so still positive. Then you're going to divide. Negative divided by negative is positive. Negative divided by positive is negative, and positive divided by positive is positive. Remember the sign here, if it is a positive, then it is above x-axis. If it is negative, that should be below x-axis, and if it is plus, that is above x-axis. So we already have now our sign table. Now we can now move on to our graph. Okay, so how are we going to graph this one? So I hope it's still clear to you. Yes, I hope it's still clear. Okay, so if I'm going to graph it here, I'm going to make use of another pen. Say, for example, I hope it's still clear. So I have here a Cartesian plane. So 1, 2, 3, negative 1, negative 2, negative 3. Of course, it still can be extended. So 1, 2, 3, then negative 1, negative 2, negative 3, then positive 1, positive 2, then negative 1, -2. Okay, so first thing we're going to plot first the y-intercept, x-intercept, the vertical and horizontal asymptote. So I'm going to use a green for the asymptotes. Okay, the asymptotes. So let's start with the asymptotes. So vertical asymptotes is -2. -2. Shoo. Okay. Vertical. So standing line. So -2. Okay, -2 here. So this is our vertical asymptote. So I can make a broken line here. Suppose that is a straight line. And then the other horizontal asymptote is +1. Okay. Then since it is a horizontal asymptote, then I can make an horizontal broken line. Suppose that is a straight line. Okay. So we can now see our vertical and horizontal asymptote. Next, I'm going to make use of the dark blue for our x and y intercept. Let's start with the y-intercept. We have -1. Okay, -1. And then for our x-intercept, we have +2. Why is it only wrong? Y-intercept, it should be on the y-axis. I'm sorry. So, oh, what happened? No, wait. Oh no. Oh no. So again, it should be on the, be careful in plotting the points. Okay, so it should be on the y-intercept, y-axis. So it should be here. So y-intercept is -1. So this one, -1. Y-intercept. No need to put this one, but I'm just going to emphasize this to you that it's the y-intercept. And then the x-intercept is 2. So we have also here 2. X-intercept, it's the x-axis. X-axis, y-axis. So we have here the x-intercept. Okay, so we are done with our plotting. So let's have now the behavior of our graph. So I'm going to use what color? So I'm going to use pink. No, red. So let's have x less than -2. So the behavior of the graph of x less than 2 is above x. Again, we have here the horizontal asymptote here. So it is not possible to have here below the horizontal asymptote, then possible here so that it can extend. Suppose it is a straight line, again, it should not be, it will not be touch the horizontal asymptote. So suppose that is our graph. Okay, so again, above axis, so that is our possible behavior of our graph of x less than -2. So going to the right, so negative numbers. Next is in between -2 and 2. So in between -2, below x-axis. Remember, we have here the y-intercept, so it should be below. So meaning from this intercept here, of course, we're not going to overlap it here. We're not going to make a line here because it now we already have the intercept, meaning it intersects on that, it touches on that point. So possible here, we're going to connect the dots and then going downward because it is below x. Yes, suppose, yeah, connect the dots. Oh my god, wait, going down because basta connect the dots, going down, it's do not mind my line. Okay, just connect the dots because it is below x. Of course, again, it is not possible to have a graph here in -1 because we already have the intercept, meaning it intersects on that line or it touches on that point. The graph touches on that point. And then moving on to x is greater than 2. So x is greater than 2, that is above x. So of course, because of the horizontal asymptote, we're not going to move above that one. So x, this is the x-axis, so we're just going to go with the flow, but we're not going to touch that line. So that is the possible behavior of our graph. So I can accept this answer. I know we're not perfect in having the graph, but I wanted to look the behavior of the graph. Then after that, so this would be our final answer after getting the domain, the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote, including the sign table. Then we can now graph that function. So, and then after that, we can now check using our demos. Ooh. So let me have this function. Is it already seen? No, not yet. So, okay, here. So that is our previous example. So I'm going to change here the function. So we have x, what's that? X minus 2. See, you have in every function you have different graph, but again, I am not into the correct answer, but I am into the process, because what's the use of those correct answers if you really don't get the process? So you should understood first the process and then check. So as you can see here, this is our graph. Again, as you can see here, the gray dot here, that is the what I told you, the x-intercept to 0, and then the y-intercept 0, -1. O, diba? Almost the same chart. Wait. Oh, see, almost the same with our graph. Okay. So it's almost the same with our graph. Okay, so again, what is our horizontal asymptote? It is on 1. So at some point of 1, we're not going to meet that line there. It will just almost on that line, but it will never touch. The same thing on the vertical asymptote here, the -2. It will never touch -2, the line of -2. It will just going to going closer and closer, but it will never ever touch that line. Oh, it looks like it touched, but it does not. That is the meaning of asymptote. Even if how close you are, yet you did not, it's not your destined one. Charot. So you still have going to move on. Life is better. Okay, so again, Desmos is not for easy answers. It's just the how going to check your, it is just on checking your answers if in the on the right track. So go back to our discussion. So again, getting the domain, the y-intercept, the x-intercept, vertical and horizontal asymptote, the sign table. So if you get that one, then you can just easily graph that one and then check the demos. So I hope you clearly understand on graphing rational functions. Thank you. Before mag-off, thank you.